Welcome back to our channel. Today, we are diving into the fascinating world of fluid dynamics and exploring a fundamental concept, viscosity. So, what exactly is viscosity and why is it important? Let's find out. Viscosity is the characteristic of a fluid that provides resistance to the movement of one fluid layer over the neighboring fluid layer. The term viscosity describes a fluid's internal friction or its reluctance to flow. Let's imagine that there are layers of fluid separated by a distance dy. In these layers, there is a change in velocity represented by du. Due to these varying velocities, there is a force called shear stress acting between the fluid layers. This shear stress is denoted by the symbol tau and can be mathematically expressed as tau proportional to du by dy, which represents the velocity gradient. If we introduce a proportionality constant, we use the symbol mu, which is known as the coefficient of dynamic viscosity or simply viscosity. The SI unit of dynamic viscosity is Newton second per meter square. It can also be measured in another unit known as the poise or dyne second per centimeter square. 1 poise is equal to 0.1 Newton second per meter square. For example, the viscosity of water at a temperature of 20 degrees Celsius is 0.01 poise. Viscosity can sometimes refer to kinematic viscosity, which is a property of fluids that is not dependent on density. Kinematic viscosity is defined as the ratio of dynamic viscosity to the density of the fluid. It is represented by the Greek letter nu and is measured in units of square meters per second in the International System of Units. In the CGS system, the unit of kinematic viscosity is called the stroke, where 1 stroke is equal to 10 raised to -4 square meters per second. Shear stress between layers of a fluid is directly related to the rate of shear strain, and this relationship is governed by Newton's law of viscosity. The constant of proportionality in this equation is known as dynamic viscosity. Fluids that adhere to this relationship are referred to as Newtonian fluids, while those that do not are classified as non-Newtonian fluids. For instance, water is a Newtonian fluid, whereas blood is a non-Newtonian fluid. Additionally, fluids can be categorized as ideal or ideal plastic. An ideal fluid is considered incompressible and has no viscosity, although this is a theoretical concept since all fluids exhibit some level of viscosity. On the other hand, an ideal plastic fluid exhibits a yield point beyond which the shear stress becomes directly proportional to the rate of shear strain. Examples of ideal plastic fluids include water suspensions of clay and fly ash. Lastly, if there is no velocity gradient and shear stress is present, then the substance is considered an ideal solid. The viscosity of a fluid is influenced by temperature. In the case of liquids, viscosity tends to decrease as the temperature rises, while for gases, viscosity increases as the temperature rises. This behavior can be attributed to the interplay between cohesive forces and momentum transfer within the fluid. In liquids, cohesive forces play a more significant role compared to momentum transfer. As temperature increases, the cohesive forces decrease, allowing for easier flow and resulting in a decrease in viscosity. On the other hand, in gases, momentum transfer is more pronounced. With increasing temperature, the momentum transfer becomes more dominant, leading to an increase in viscosity. This temperature-dependent relationship between viscosity and fluids has significant implications in engineering. It helps determine the flow characteristics of fluids in various applications such as pipelines, lubrication systems, and hydraulic machinery. For instance, motor oil, or engine lubricant refers to a range of substances employed for lubricating internal combustion engines. The primary purpose of motor oil is to minimize friction and wear on moving components while also keeping the engine clean. Viscosity plays a crucial role in determining the effectiveness of these functions. To classify motor oils based on their viscosity attributes and how it changes with temperature, the Society of Automotive Engineers (SAE) has devised a numerical code system. This system provides valuable information about the viscosity characteristics of various oils, aiding in the selection of appropriate oils for specific engine requirements. That concludes our discussion on viscosity. We hope you found it both informative and captivating. If you have any questions or would like us to delve into other topics related to fluid dynamics, please don't hesitate to leave a comment below. Remember to show your support by liking this video, subscribing to our channel, and activating the notification bell to stay informed about our most recent content. Thank you for watching.